In this video, we'll review how to find all the major components of a quadratic function, as well as how to graph a quadratic function. Here we're given f of x equals negative 2x squared plus 5x plus 3. Our first question is, does the parabola open up or down? This is determined by the sign of a, or the sign of the leading coefficient. Here a is equal to negative 2, and since a is negative, the parabola opens down. Next, we're asked to determine the equation of the axis of symmetry. For this, we use the equation x equals negative b divided by 2a. Again, a is equal to negative 2, and b is equal to positive 5. So our equation will be x equals negative b divided by 2a. Well, b is equal to 5, and a is equal to negative 2, so we have 2 times negative 2. So here we have negative 5 divided by negative 4, which will be positive 5/4. So the equation of the axis of symmetry is x equals 5/4. Next, we're asked to determine the coordinates of the vertex. Remember, the vertex lies on the axis of symmetry, so the x-coordinate of the vertex will be 5/4. And then to find the y-coordinate, we need to determine f of 5/4, or substitute 5/4 for x into our function. So f of 5/4 is equal to negative 2 times 5/4 squared plus 5 times 5/4 plus 3. Well, 5/4 squared would be 25/16, so we'll have negative 2 over 1 times 25/16 plus 5 over 1 times 5/4 plus 3. Here a factor of 2 simplifies. This simplifies to 1, this simplifies to 8. So now we have negative 25/8 plus, this is going to be 25/4, but to have our common denominator of 8, this is equal to 50/8 plus 3 is equal to 24/8. So now we have a common denominator of 8. We'll add the numerators. Negative 25 plus 50 is 25, plus 24 is equal to 49. So the y-coordinate would be 49/8. We will convert this to a decimal when it comes time to plot the point. Now we want to find the x and y-intercepts of the graph. So to determine the x-intercepts of the function, we're going to set y, or f of x, equal to 0 and then solve for x. So we want to solve the equation 0 equals negative 2x squared plus 5x plus 3. Let's go ahead and factor out the negative and then see if it factors. Factoring a negative out, it's going to change the sign of all of the terms. So we'll have 2x squared minus 5x minus 3. I think this will factor. Factors of 2x squared would be 2x and x. Now we want to place the factors of negative 3 in here so that the sum of the inner product and outer product would be negative 5x. So we'll put minus 3 here, that's negative 6x. Positive 1 here, plus 1x does equal negative 5x. So this product is equal to 0 when 2x plus 1 equals 0, or when x minus 3 equals 0. So here we'd have x equals negative 1/2, and here we'd have x equals 3. These are the x-intercepts, but we do want to express these as ordered pairs. So there are two x-intercepts. One of them is negative 1/2 comma 0, and the other one is 3 comma 0. Now to determine the y-intercept, we want to set x equal to 0 and then solve for y, or solve for f of x. Well, if we set x equal to 0, notice how we would have 0 plus 0 plus 3. So the y-intercept is just the point 0 comma 3. So when we have a quadratic function in this form, the y-intercept is always just going to be c. Now let's take all this information onto the next slide and continue. Now we want to graph this function. Let's take a look at the information that I provided here from the previous slide. Notice for the equation of the axis, x equals 5/4, I converted this to a decimal. 5 divided by 4 is 1.25, which again is the x-coordinate of the vertex, and 6.125 is equal to 49/8, which was the y-coordinate of the vertex. Let's start by sketching the equation of the axis of symmetry, which is x equals 1.25, somewhere in here. Next, let's plot the vertex, which is on this axis. It has the coordinates 1.25, 6.125, so somewhere in here. Next, we'll plot the intercepts. So we have the point 3, 0 here, and we have the point -1/2, 0, which would be here. Notice these 2 points are equidistant to the axis of symmetry. And then we know that the y-intercept is the point 0, 3, which would be this point here. There must be a mirror image on the right side of the axis of symmetry, so there must be a point somewhere in here. And this is more than enough information to sketch a nice graph of our function. It will look something like this. Now we want to determine the domain and range of the function. Remember, the domain is a set of all possible x values, and the range is the set of all possible y values. So again, domain means x, range means y. Well, the domain of any quadratic function will always be all real numbers, which expressed using interval notation would be from -infinity to +infinity. Looking at the graph, it is moving down quickly, but it's also moving left and right forever, verifying our domain. Then for the range of the possible y values, notice how the largest y value is the y-coordinate of the vertex, which is 6.125, and then from there, all of the y values are less than that. So we can express the range using interval notation as the interval from -infinity to 6.125 or 49/8, and it does include this value, so we have a closed interval here. We could also express this using inequalities as y is less than or equal to 49/8. And then for the last question, we want to determine the intervals for which the function is increasing and decreasing. So if you can imagine yourself as a small person walking along this function from left to right, if you're walking uphill, the function is increasing. If you're walking downhill, the function is decreasing. But it is important that we be walking from left to right. So the function is increasing on this interval and decreasing on this interval, and it changes from increasing to decreasing at the vertex. So the function is increasing on the interval from -infinity to 1.25, the x-coordinate of the vertex. Remember, 1.25 was 5/4. It's going to be open on 5/4, and it's going to be decreasing to the right of 5/4, or the open interval from 5/4 to +infinity. Okay, so I hope you found this review helpful. Thank you for watching.